Welcome. This evening, my name is Ann Lemaster, and this evening we're going to be discussing Chapter 18, Nutrition and Metabolism. Here, speaking of nutrition, is a diagram showing you what a healthy, nutritious meal should include. So every time you eat, about 50% should contain fruits and veggies. 25% would be the grains and starches, and then the other 25% protein. And again, this is just kind of a guideline to help you eat healthier, because we Americans don't really like to eat healthy on the whole. Okay, so nutrients are what are needed for survival. Some nutrients are called macronutrients. Let me highlight macro here. Macro means large. So these are nutrients you need in large amounts. And of course, they're the carbohydrates, the proteins, and the fats. Micro, you may remember, means small. So these are not unimportant. You just don't need as many of them. And these are vitamins and minerals. Essential nutrients are nutrients that you cannot synthesize. In other words, you cannot make these, or your body cannot manufacture them. So there are some amino acids that are essential. It's about 8 of these, and they're essential for making the proteins of your body. And then fatty acids would help you make things like triglycerides or phospholipids or things like that. Okay, let me erase my drawings here. Appetite control. When we're referring to metabolism, basically we're talking about chemical reactions in our body. Anabolism is building, whereas catabolism is breaking down. So anabolism would be building, and one of my students reminded me of anabolic steroids. They make you larger. And for me, I remember catabolism, how cats like to shred curtains. I'm not anti-cat. Sometimes cats like to claw things and make things smaller. So an example of anabolism would be you building new proteins or making new hormones. An example of catabolism would be what you're doing after lunch. You're taking, say you ate a ham sandwich, you're taking the ham and the bread and breaking it down to the amino acids and the carbohydrates you need. Appetite is the drive that compels us to seek food. And your body has several ways to regulate appetite. One is insulin. Insulin, as you know, is the hormone made by the pancreas that causes glucose to be taken up by the cell. And this is an appetite suppressant. The other appetite suppressant is leptin. Sometimes you'll see infomercials at 2 in the morning about this, but this also suppresses appetite and increases metabolic rate. The other two, neuropeptide Y and ghrelin, enhance appetite. Okay, let's talk about some of the macronutrients we need. The first one is the mighty carbohydrate. And if you remember, carbohydrates, particularly glucose, is what our cell uses to make ATP. So glucose is what's needed for cellular respiration. Glucose is a monosaccharide. Sucrose, which you might put in your coffee or on your cereal in the morning, is a disaccharide, meaning it's made up of 2 sugars, glucose, and this is fructose. If we come over to the bullet points here, excesses in carbohydrates, of course, can lead to obesity and cavities and some other nutrient deficits. In other words, if you eat our carbs, you may not get enough fats and proteins. Deficiency can lead to metabolic acidosis, and that's in lowering of the body's pH, which is not good, and weight loss, which can be good. Now, how we eat carbohydrates? Well, what we usually ingest is what's called a polysaccharide. And remember, poly means many sugars. And if we eat plants like potatoes, we'll get starches. And this is, starch is just a string of glucose molecules. And we store somewhat a limited amount of glycogen, which is how animals and humans store glucose. Simple sugars, or simple carbohydrates, come from milk sugars, cane sugars, beet sugars, molasses. Monosaccharides, such as glucose and fructose, come from honey and fruits. Carbohydrate sources, well, actually, this is cellulose, right here. Again, this is a string of monosaccharides. However, what's different in this, this one's used primarily for support of plants and structure. We are unable to digest it. In other words, we lack the enzymes to break down these bonds. So this is what we call fiber or roughage, and kind of helps us remove waste. Okay, so what do we do with carbohydrates once we ingest them? Well, we break them down. And again, the main molecule, main monosaccharide of choice, or what our bodies prefer, is glucose. However, should we take in fructose, say we eat a lot of fruit or we drink high fructose corn syrup, fructose and glucose are what are called isomers. In other words, they have the same chemical formula of C6H12O6. Another isomer is galactose, and this is a monosaccharide found in milk sugar. And again, galactose is easily converted into glucose. And then once these are converted into glucose, then they enter the stages of cellular respiration. So what do we use carbohydrates for? Well, when we digest carbohydrates, such as starches, we make glucoses. Sucrose is digested into glucose and fructose. Maltose is plant sugar. And lactose is glucose and galactose. And then what can happen once we have monosaccharides is cellular respiration. In other words, this is a catabolic reaction where we break it down into ATP. Or we can have some anabolism going on here. Glucogenesis or glycogenesis, which we convert glucose into glycogen. And lipogenesis, which means we convert the glucose into fat. Lipo referring to fat, and anytime you see genesis, genesis means building or creating. Okay, I know this slide looks confusing, but we're just going to focus on a few things. First, let me get my handy-dandy pointer here. Okay, this is a cell, and it's a cell undergoing cellular respiration. So it's just reminding you of the steps of cellular respiration. Here, in this image in the upper right corner here, this is showing you how glucose is converted into glycogen. So this is glycogenesis. And if you're curious, down here is lipogenesis. And what we do, or what our bodies do, is convert glucose into potentially glycerol and glycerol is the backbone for triglycerides. In other words, one glycerol molecule and 3 fatty acids equals 1 triglyceride. Carbohydrate requirements. I'll let you read through that. Our average diet, we take in probably around twice as much as we need. And of course there are good carbs, which are complex carbohydrates and take a while to break down and are more filling. And then we have bad carbs, which are abundant and unfortunately very tasty. So again, these are more glucose-based or just contain simple sugars and are easily digested. Okay, lipids, again, is another macronutrient. These are things like fats, oils, and they can use to build substances like phospholipids, if you remember cell membranes, and cholesterol, also found in lipid membranes, and the basis for your steroid hormones. Again, this here is a triglyceride, 1 glycerol molecule, 3 fatty acids. This is how we're going to store energy, and that's its main function, energy storage. Obesity can be caused by excess lipids, as in higher cholesterol levels and increased rate for heart disease. We'll talk about those in a minute. Deficiencies can lead to weight loss, which is not necessarily a bad thing. However, you can get skin lesions, again, not being able to replace those phospholipids, and hormonal imbalances. Cholesterol, which is a lipid, is the building block for estrogens and testosterones, among other hormones. Okay. Now, the triglycerides vary as far as what their source is. Saturated fats are found mainly in fats of animal origin, such as meat, eggs, milk, and lard. And saturated fats can cause an increased risk of cardiovascular disease. Unsaturated fats are found in seeds and nuts and plant oils, like olive oils. And cholesterol, it is found in, again, meat-based fats, such as the liver or the egg yolk. No cholesterol is found in plant origins. And what do we use lipids for? Well, to build. Anabolically, we build phospholipids and cholesterols and triglycerides. Why we store fats over, say, storing carbohydrates comes down to this bullet point here. We get more energy from a gram of fat, so we get 9 calories per gram, compared to only 4 calories per gram with carbohydrates and proteins. Okay, and then again, a calorie is how much potential energy a food contains. So we store fats because they are going to give us more energy. What this is showing is what happens to fats. We have our friend, the term hydrolysis, meaning using water to break it down. The glycerol is converted into glucose, and of course that is the main component in cellular respiration. Glycerol can be converted into acetyl coenzyme A, which is a component in the citric acid cycle. Fatty acids can be used to build fats or broken down into ketone bodies, and those can be converted into acetyl coenzyme A. the first reactant in the citric acid cycle. And of course, once things enter the citric acid cycle, they're oxidized, and that is used to build energy in ATP and heat. Okay, so once you digest triglycerides, your body can use them to build triglycerides, lipoproteins. We'll talk about lipoproteins in a moment. Other fatty acids, except the essential ones, cholesterols, and phospholipids. Okay. Here's an example of an essential fatty acid. That's linoleic acid. And here's why lipoproteins are so important. What lipoproteins are molecules that are a combination of proteins and lipids. And you have a couple. VLDL has high triglyceride content. And the two you probably have heard of is LDL, bad cholesterol, or HDL. LDLs, high cholesterol content. In other words, they carry the cholesterol around in the blood, about 75%. If you remember, blood is mostly water. Cholesterol is a lipid, so lipids and waters don't get along, don't mix. So you need transport mechanisms, and that's what the lipoproteins do. However, low-density lipoprotein can make deposits of cholesterol in fatty plaques around your arteries and veins. This can lead to cardiovascular disease. The good cholesterol is high-density lipoprotein, and again, this also carries cholesterol, but it takes it directly to the liver, so the cholesterols can be removed. And of course, you have good fats and bad fats. The good ones are pretty good. Omega-3s, avocados, nuts. The bad fats are equally tasty. Some might argue even more so. Things like butters and chips and things like that. So according to the American Heart Association, 30% of our daily calorie intake should be from fats. Proteins. Again, these are the last of the macronutrients. And, well, we are pretty much machines made of proteins, so they do an incredible amount of stuff. The waste product in protein metabolism is urea. It's usually lost through the urinary system. Excesses can lead to obesity. Deficiencies could be weight loss, muscle wasting, anemia, and a slowness of growth. So what happens to proteins when we eat them? Well, they're digested catabolically, and then the amino acids can be used to build proteins. So here's some anabolism. They can make structures such as muscle, make enzymes, hormones, plasma proteins. However, should our calories be restricted, the amino acids can be converted into glucose or other components of cellular respiration, so they can be used to make energy. And what this is showing here is how amino acids are used or participate in cellular respiration. First, you have to deaminate them, which means you remove the amino group. And you can convert them either to acetyl-CoA or other components of the citric acid cycle, and then you make ATP and heat from that. Protein sources, you can read through those. Remember, 20 types of amino acids are used to make all the proteins in your body. You have non-essential, 12, and essential are 8 to 10 of them. And I don't remember them off the top of my head. Surprise, surprise, we probably take in more protein than we need. Protein should be 10% of a person's diet. And this is because we normally don't use proteins for ATP. We only use proteins for ATP when we're not eating enough carbohydrates and fats. I believe it's called protein sparing. I believe I've covered pretty much this slide just during our lecture. Again, whatever you eat, carbohydrates, fats, and proteins, they will be used in metabolic processes. They'll be either used to make ATP, and that's catabolism, or they'll be used to make what you need, and that is anabolism. Now, speaking of, well, I guess I didn't skip one. Speaking of, now let me go back here. Okay. Oh, we're talking about energy expenditures. Most of us at this moment are sitting at rest or talking, and that's about, we are burning energy-wise about 100 calories per hour. So should we be doing something more, such as walking up the stairs, we can burn up to 1,000 calories per hour. Now, along with how we expend energy through exercise, we also use energy to maintain what's called our basal metabolic rate. And that's how much energy we need when our bodies are at rest. Lots of things determine your basal metabolic rate: gender, body size, body temperature, hormones. And what the basal metabolic rate includes is muscle activity, such as your heart beating, diaphragm contracting. Also helps to maintain body temperature and for growth when growth is occurring. So the gist of this slide is that you should take in what you use. So if you take in more energy than you need, that could lead to weight gain. Now, desirable weight, well, that's a toughie. To the right are just pictures of what a desirable person looked like as time. This is earlier in the Baroque period. Here we have the turn of the 19th, from the 19th to the 20th century, and here we have now. Desirable weight's difficult to determine. A lot of cultural things going on. But what we use now is called the body mass index. And it assesses our weight and considers our height. If you are overweight, you have a BMI of 25 to 30. Anything over 30 is considered obese. And about 60% of Americans fall into either the overweight and 30%, well, 60% if you add together the overweight and obesity. 30% of Americans are considered obese. And here's a chart to help you determine your BMI, and I'll let you take a moment and do that. Okay, now we're coming to the micronutrients. We have vitamins. Vitamins are organic. And basically, vitamins do things like help enzymes work better. They cannot be synthesized by the body. Some are fat soluble, A, D, E, and K, meaning they can, too much of these can be stored in your fat. Some are water soluble, and these are the B vitamins and the C vitamins. So if you eat a lot, or if you take a lot of B and C, and vitamin B and vitamin C, you would just excrete that out through the urinary system. Here are some fallacies. Let's go through that. Okay. Minerals. Minerals are inorganic. So there are things like sodium and potassium and iron. They're usually extracted by the soil from plants. And we cannot manufacture minerals, so we have to obtain them from our diet. And about 4% of our body weight. These would be things like calcium and phosphate, your skeletal system. And speaking of the skeletal system, that's where most of our minerals are located. They play a very important role. For example, hemoglobin, needed to carry oxygen and carbon dioxide. Iodine is needed to make hormones. Phosphate groups for phospholipids. They're structural, hemostatic, and of course some of them can lead to toxicity. I'm thinking of the heavy metals like lead and mercury, but there's other forms of toxicity as well. You have major minerals, the ones that you need the most of, and those are listed here. Most of these you've encountered before. And again, calcium and phosphorus are the most. Trace elements are things you need in smaller amounts. So iron, manganese, copper, selenium, chromium. You might have seen these in your multivitamin if you've taken them. Sometimes multivitamins contain minerals. Iodine, naturally, there's no way to ingest that, so that is why it's found in salt. Clinical applications, you need to be careful with dietary supplements. Sometimes these are not regulated by the FDA, so they may not contain what they say they do. They can interact dangerously with medications, and sometimes there's not really any scientific evidence that they do what they're supposed to, or what they're marketed to do. So eating healthy. Eating healthy, well, that's a tough one. Here's what I had grow up with, the classic food pyramid. Eat carbs, fruits and veggies, meat, milk, and fats. Healthy eating varies with age and sex. And I find this amusing because if you're looking at weight loss guides, you usually eat the middle part of the triangle, the weight loss trapezoid. But I'm sure I'm not alone here in liking the paper hat of happiness here, the fats and the carbs. This is the food pyramid guide. This is a very confusing way. They've updated the pyramid. This shows us to exercise, to get off our butt every now and then and take a walk. We have grains, veggies, fruits, oils, milk, and meats. And the size of the colored triangles represents the amount we're supposed to eat daily. And yes, you are supposed to exercise daily. Another aspect of nutrition is malnutrition. And that comes in a couple different forms. You can either be deficient or undernutrition, or you can get an excess of nutrients. Here is a pirate. Sometimes, this is Patchy the pirate. Scurvy can be caused by loss of vitamin C, and this child here, disorder, comes from lack of protein. The child in the picture suffers from coarse, and I believe I'm pronouncing that properly, but I don't think so. Other aspects are starvation. And a healthy human can survive 50 to 70 days without food. What gets us is water. We can only withstand about 3 days tops without water. Now, not only can starvation be due to just a lack of food, but there are a lot of disorders such as anorexia nervosa and bulimia, which have psychiatric and social ties as well as nutritional ties, or nutritional psychological and sociological causes. And I believe that is the end. If you have any questions, now would be the time to ask. But if not, thank you very much for spending some time with me.